Hi everyone, it's good to be with you again. We've been applying those cool rules of probability to some interesting situations. Well, I hope you found them interesting, and we've got a few more scenarios to look at. So let's get straight into it. Remember to revise all the probability rules, and then you'll be familiar with how to apply them, because the problems can look different. But if you know the rules and you keep yourself on an even footing and don't panic, you'll be able to answer any question. Let's have a look at this one. So applying our concept map, we recognize we've got a situation here where there's a survey that's conducted amongst a particular sample of boys and girls. And we recognize within the survey there are 100 boys and 60 girls. So immediately, before I've even thought about looking at the data, I'm going to recognize that the size of the sample is going to be 100 plus 60, which is 160. So it now tells me that this information is being tabulated in the data, and there it is. Nice table. These are the boys, these are the females, and these are the ones that watch TV during examinations. Well, I hope they did watch TV because they were trying to learn a little bit more. There's always stuff on various channels that is going to help you with your exams. So please make sure you're one of those that tunes in. These are the ones that didn't watch TV during the exams. So we recognize that they didn't watch TV. The total sample, that's the number in the sample, is 160. So what are we asked to do? We recognize there's some missing information, and we need to find what the values of A and B are. Well, I think that isn't too difficult, but let's approach this problem quite logically, because we have to look at what information we've been given and what information we have to find. So let's have another look at it, and I've got some space here for us to do just that. So the first thing I recognize, which is a very important factor, is that in here is the total. And I recognize the totals add up both down and across. So if I were to take the number of females and I say 12 plus 48, that will give me a total of 60. So there are 60 girls in the experiment, and I know that's true. I also know that I was told that there were 100 boys. So I can recognize that 80 plus A will give me 100. So it's not too much of a stretch to recognize that in terms of this, I need to recognize that A is going to be 20. But what about B? Well, you can see that if we say 20 plus 12, that gives us 32. It confirms for us that we are right. But what about B? If we add up going down, we can recognize it's 80 plus 40. 80 plus 40 is 120. So this, I think, should be 128. Let's make absolutely sure, because when you're doing one of these tables, you need to make sure that things add up going down and across. So does it? 128 plus 32, or plus 30, plus 2 will give you 130, plus 30, yes, it gives you 160. So it does add up. This number of 128 for B is correct, and the number of 20 for A is correct. Now guys, you might not have been expecting this sort of problem in a probability question. It's really just a logic question. And you just need to be able to practice finding out about these equations and setting them up and recognizing that the sums of the rows and the sums of the columns have to come out, and they have to all equal each other and equal the final total at the end. Very good. Let's now move on to the probability questions, which are quite interesting. It says, are the events being male and did not watch TV mutually exclusive. Now, before we go and dive in and look at the data and try and work out what's happening here, there are many ways to answer this problem. Let's remind ourselves, what does mutually exclusive mean? It means that you can't do those two options at the same time. So in this case, the question was being male, and the other one was did not watch TV. So you can't be male and watch TV at the same time. But let's look at the data. Did not watch TV, by the way. So if these are all the male situations, there's the males that did watch TV. These are the males that did not watch TV. In other words, it's the set of 20 that did not watch TV even though they were male, and they were out of the total of 100. So I hope you can see that being male and did not watch TV, there are 20 young men who did not watch TV. Now, if those two sets were mutually exclusive, what could you predict? Well, they can't happen at the same time. That means they've got to be empty. The intersection between them has to be empty. There have to be 0 in them. But here we see there are 20 in them. So these are not mutually exclusive events. So the answer is, are they mutually exclusive? And the answer is no, because what we can say, the intersection of maleness and not TV, that intersection is the number in that intersection is equal to 20, and therefore it's not equal to 0. If they were mutually exclusive, those two sets would not intersect. So suppose if you're looking at this, you might say to yourself, well, maybe it could be a way of drawing a Venn diagram to be absolutely certain. And maybe that will be helpful in our next problem, in solving the next problem. But let's have a look and see where we're at. So here we go. Let's look at the next question. Said, if a learner who participated in the survey is chosen at random, what is the probability that that learner watched TV during the exams? So I think my idea of taking my 160 learners, and let's just divide them into two categories. Into the category that watched TV and those that didn't watch TV. So if we do that, we'd recognize that in this category here, the number B, we had 128 of them. So this is those that watched TV. So these are the TV, and this is the ones that did no TV. And we recognize there were 32 of those. We recognize there were 128 of those. So there are two ways of calculating the probability of those that did not watch TV. And the easy way, the straightforward way, is to count up those that did not watch TV, and we'll simply say the following. We'll say the probability of those that did not watch TV, no TV, is going to be equal to the total number of learners in the survey, which was 160, divided by those that didn't watch TV. And if we use the calculator, we will find, let's use the calculator to find the probability there. We're wanting 32 divided by 160, and that's equal to 1/5, 1 in 5, or 20%, 0.2. So I'm going to write it as a percentage, and we're going to say that is equal to equal to 20%. So that's one way of doing that calculation. Is there another one? Of course, we can use the complement rule. Because if you look at this, you can see 128 watched TV in the sample space. Those that were not part of those that watched TV are in the complement. Not watching TV is a complement of those that watch TV. So let's work out what the probability is of those that watch TV. And we're going to say that the probability of those that did TV is going to be 128 out of 160. And again, if we use the calculator, we're going to say the following. 128 divided by 160, 128 divided by 160 equals 4/5, 80%, and we're going to write it down there. 80%. And the reason I'm doing that is I want to use the complement rule, which says that P, no TV, or the complement of TV, is equal to 1 minus P of TV. And I hope you can see that's 1 minus 80%, which is, in fact, the 20%. And so we've got two answers using two different methods, and they both agree. Isn't that exciting? We've got the right answer. Okay, let's move on. So if a learner participates in the survey, what is the probability that the learner is not male and did not watch TV during the exams? Now guys, this not and can be so confusing, but really it's not difficult. So let's be very clear about it. If it's not male, then it's female. And if it's not watch TV, then what we're asking is what's the probability of those females that did watch TV? So not male means female, and not watch TV, the opposite of that, not watch TV, is watch TV. So what we're wanting is the complement, and it's important that we look at that word that says and. Very important. So the opposite or the conjugate of this, or the complement of this, is watch TV. So what we're really asking is we recognize we're not worried about them, that they're not male. So we're worried about the females. So we're worried about these ones. And if we looked at this, the females that did not watch TV. So the females that did not watch TV are those ones there. So these are not male and they did not watch TV. It's 12 of them, and we've isolated them exactly. So the probability of those that are not male, in other words female, and that did not watch TV, no TV, we'll recognize that that probability is going to be 12 out of the 160. And so if you do use the calculator again, we recognize we've got 12 divided by 160. We'll get a percentage, convert it to a decimal, 0.075. That gives us 7.5%. 7.5%. Good. I hope you can see how using the table and using our rules can help us confirm our answers. I hope you can go and do this using the complement as well. But let's quickly recap the rules that are so important that we don't make a mistake with them. So the rules that we've covered today are, first of all, what the sample space is, remembering that the sample space, the probability of the sample space is 1. what the relative frequency is, and you can get asked questions about that, the important rule for calculating complement. Make sure you're familiar with that. And then the difference between union being or and intersection being and, recognizing what mutually exclusive is and applying the or rule. This is the or rule for mutually exclusive. And then for those that are not mutually exclusive, recognize that there are elements in the intersection, and we have this longer rule where we subtract those elements in the intersection because we don't want to count the elements in A and B or X and Z twice. So we've got to subtract them from the intersection. Well, guys, I hope that makes a lot of sense. I hope it gives you confidence that when you're facing a question on probability, there's a very good probability that you're going to get the answers correct. In fact, I hope the probability is 1. From me, goodbye.